Hey everybody, welcome back to another adventure in CIS 17A. Today we are going to be reviewing lesson number 11. So we're going to wrap up everything with arrays in this lesson. For the pages, we're going to be covering pages 405 through 424 in the textbook. All right, so what are we going to talk about? We're going to talk mainly today about how you can use arrays with functions. So we'll also talk about two-dimensional arrays and stuff that we can do with that. And that's pretty much it. All right, let's go ahead and start off by looking at a simple program. So what does this program do? It's very simple. All it does is declare an array of size 5 and then use a for loop to call a function called print, which it passes the elements of the array one at a time as it iterates through the loop. So we can see here's my print function. All it does is print out the value of num. All right, so nothing really new here. So let's go ahead and see how we could, let's go ahead and run it first and just see that what it does. So we can see it's printing out all the numbers that were passed using this list and implicit sizing for the array. So 10, 15, 12, so on and so forth. So let's see how we could take this functionality of printing something out and move it into a function. All right, first thing you need to do is in your prototype for the function, you need to include square braces just like that. All right, step number 2, make sure that down here in your header, you also have square braces. Next, up here, notice that we got squiggly line now under num sub I. So we are going to pass just the name of the function. And that's it. So now we are going to take this for loop out of here and use our print function to call down here and print everything out one at a time. Oh, that's right. There's one other thing we got to do, and that's why I like using Visual Studio. See the red squiggly line here, it says size. Well, there's nothing down here called size, and there's no global variable called size. So that's the other thing that we need to do is, in addition to putting the square brace, we also need to pass in an integer. And in this case, it would be a constant integer that represents how big the thing is, or how many elements there are in the array. So we're going to go ahead and pass in size here as a second argument, and then pass it in down here as a constant int as well, and that should make the red squiggly line go away. Okay, so there you go. So that's the 4 things that you need to do. You need to add the square brace here, pass in just the name of the array, and then add another variable in the parameter list that represents the size for the for loop. Now, it's worth noting that you don't have to do this. It's just that you're probably going to do this, because if you're going to pass an array to a function, it's likely that you're going to have to know how big that array is to do processing on it. So let's go ahead and run the program and see what happens. It should do the exact same thing as it did just a moment ago. Oop. Oh, I forgot to put in the, that was the address of num. So now we got to put num I. And there we go. So now we got it printing out everything the same way that it did a moment ago. So why would we want to do this? Well, look at how much it cleans up the main function. So in the main function, this is much more readable. We know how big the array is, what's in it, and we know that we're going to print it, right? And then we can just leave all the functionality up to the function. So there you go. So that's how you can use an array in a function call. All right. So a lot of this is just noting what I just said. Couple things to note about when you pass arrays to a function is that you are passing it effectively by reference. And I'm looking for where it says that. And it should say it down here maybe. Maybe it's after. Oh, it's probably after it says that. Yeah, there it is. All right. Anyways, I'm looking for the text where it actually says it. Oh, there we go. Nums is effectively a pass by reference or a call by reference. So remember the difference between calling a variable, calling a function, and passing it a variable by value. You're just copying the actual value up into a copy of that variable, possibly with even a different name. Well, this is a function call, not a header, but and when you pass by reference, when you use the ampersand, remember that it actually is referring to the variable that's in the argument list. So it's going to change that value. When you pass an array to a function, it doesn't create a copy of every single thing in the array up to this variable. Remember that the name of an array is actually the memory address of the first thing in the array. So when you call this, this is now a reference to this one here. So what we could do is we could create another function, so just to illustrate what's going on, we could create another function called reset, and then we'll pass it the same thing. Okay, and then let's do this. Let's go here, and then make this our header. Okay, and then I'm just going to copy this for loop. And this time, we're just going to reset everything. So we'll just reset everything to a value of 0. All right, now up here, let's go ahead and just see what happens. So we're going to print, we're going to call reset, and pass it num and size. And then we're going to go ahead and call print one more time and see what happens. Okay, so there you can see what happened. The first time we called print, it printed out the values that we initially provided here. We called reset, and then it set everything to 0, so that the next time we called print, everything printed out as zeros. So that's an important thing to note, is that even though we don't have the and symbol down here like we would for a reference, when we use these square braces, this is effectively a pass by reference function call for the array. So just keep that in mind. Now, if you do want to prevent a function from modifying the array, like in a print function, there's no reason to allow it access to the data and modify it. We can just simply add the word const here and put it here. Okay. And what that does is it makes it so that this is now a constant array, and it will not allow you to modify the value here, right? Which is exactly what we want, because it's just printing things out. So for example, if I added the const here, go ahead and just paste that in. And put it here. We should get an error message eventually. It's not finding it. Let's go ahead and just compile it. Why is it not compiling? Oh, because it's currently running. Okay, so now, there we go. So now it's telling us, hey, you can't do this. So it says expression must be a modifiable value. So we made it a const so that it would not be able to do it. So you should do that wherever you know that you're just printing things out and you're not going to ever modify the values in it. Use a keyword const. Now the other thing to note is that putting const here for the size of the array is generally not all that, it's not that helpful to do that. And the reason for that is because it makes it so that you could only call the function on arrays that have the exact same size. So they would always have to be, or actually no, that's not true, because you could just create multiple consts up here. So you have like size 1, size 2, size 3, and then you'd actually just pass the constant in there. So yeah, I take that back actually, because the book doesn't use const. The book just puts int, and so while I was getting ready for this, I was kind of wondering why does the book just use int? Why don't they use const? And at one point they show how right here, they show how you could have two consts with different sizes, and you could call the same function on two different arrays, each one having their own size, or each one is of a different size. So, but yeah, as I was doing that right now, it would still work if it was constant. So I don't know why they're choosing to just use int. I disagree. Textbook, that should be a constant int. All right, but we'll leave that for another debate for another time. Okay, let's see what else. Okay, yeah, they're just saying the same thing here. That it's going to be a reference variable. Okay, and here they're showing how you could double everything in the array. So instead of resetting everything to 0 like I did in my example, the book just shows you how you could take everything, and because it's a pass by reference, you could double it. So originally it was 1, and after calling the function, all the original values were doubled. Okay, so this is basically the same example that I just showed you, except for they're calling show the values to show the original, double array to multiply everything by 2, and then showing the values. So again, they're just showing that it's passed by reference when you call a function. Here, this is what I just said. If you want to use const, that'll make it so that they can't modify the array. Okay, I am going to skip over this section. This is just a big example. I do encourage you guys to go through and read it and understand it. It'll help you in understanding how functions can be used with arrays. Okay, so all the stuff that's in gray I leave up to you guys. Here's some problems you can work through. All right, moving along. Two-dimensional arrays. So a two-dimensional array is generally thought of as a collection of rows and columns where the rows represent something and the columns represent something else. So this is a common way of setting things up in a database. So for example, rows might represent like a student, and columns might represent something like an exam score. And if that sounds familiar, then you must have gone in here and looked at what the lab assignment is. All right, so for example, you could have a student, and then that student got a 78 on the first test, and then a 99 on the next test, and then the student got a 65 on the first test, and then 89. So in this case, the rows would represent different students. The columns, moving from top to bottom, would represent test scores. Notice that the indexing is the same as in a one-dimensional array where everything starts at 0 and ends at the size -1. So here we can see this is row 1, and the way that we write down that it is a two-dimensional, or the way we declare a two-dimensional array, is we just have to put 2 of these square braces where the first thing represents the number of rows, the second thing represents the number of columns. So you can see this is row 0, row 0, row 0, row 0, column number 0, column number 1, column number 2, column number 3. Okay, so that's how you can figure out which subscript maps onto which cell in what is effectively a table. All right. Okay, here they're just showing you, I don't know why they're showing you this. This is basically the same thing that they showed you up here, except for it's kind of confusing because even though this represents a row, it looks like a column because the zeros are all in a column, but this is representing all the elements of the first row, right? Remember that first thing represents the row number, right? So even though we're stacking them up like this, like that's how they look in code, you got to keep in mind that we're looking at a row here. So there's row 1, and then there's row 2. Here they are just modifying one of the elements. Here they are just printing something out. Okay, and then here they go through this long example of how many divisions there are in a company, and then how many divisions there are in a company, how many quarters went by, and then you're entering what represents how much money you made for that division that quarter. And then you're going to go through and you're going to add everything up and see what the total sales were for the whole company over all those different periods. So you can see that once you move into 2 dimensions, everything gets much, much larger, much, much quicker. And we're having to enter a lot of data here before we can get our results. Okay, so how would we initialize, excuse me, how would we initialize a 2-dimensional array? There's lots of different ways you can do it. What you could do is you could just put curly braces around each row. So that would be row number 1, that would be row number 2, and that would be row number 3. And by the way, the easy way to remember what a row is versus what a column is just think of like the Parthenon, right? So think of the way things are oriented. So I'm going to do a quick little digression here. Parthenon. So when we're looking at the Parthenon, we would never look at one of these very, very large, vertically oriented things and call them a row, right? We would always refer to these as a column. So that's the easy way to remember it inside of a table or a 2-dimensional array, is that when you're looking from top to bottom, that's a column. When you're looking from left to right, that's considered a row. All right, so hopefully that little visual example helps you remember. Now, to make it more visually represent a column versus a row, you can also do it this way. So you can just, after putting the comma here, you can press enter, and some compilers will automatically line it up for you, but sometimes you'll have to manually just hit tab and line things up yourself. But this is the preferred way most people declare multi-dimensional arrays. It's just easier to visually represent it as a table with rows and columns. Okay. So here they're just showing you row 1, column 0. So that's row 1, column 0 is set to 7, right? Row 2, column 1. So that would be row 2. Remember, you start from 0, 0, 1, 2. Column 1, 0, 1 is 3. So we can see that here and here. Okay? All right. Just again, showing you how to visualize what the column looks like. So yeah, both of these. Oh, and then yeah, the curly braces are optional. So you could just put everything in a long list like this. Now that's very uncommon because it's not very readable. And then this is even worse. Here they're just randomly omitting things, and then the things that are randomly omitted will be initialized to 0. But this is very uncommon. I don't know why someone would want to do this. So again, most common way to initialize an array is like this. Okay, moving along. So how do you pass a 2-dimensional array to a function? So let's go back over here and let's see what we have to modify. Okay, so we're going to go ahead and this time declare a 2-dimensional array. So we're going to add another square brace here. And notice that I get a little red line underneath the second set of square braces. When you declare a 2-dimensional array, you have to provide the size here to the declaration. Now, the other thing that we're going to see is that if we go to try to print, we're going to also have to put a constant in the second braces here when we go to call it. You can see the red squiggly line. So for that reason, the most common way to provide that second parameter that represents the number of columns is to use it as a global constant. And you may say to yourself, well, I thought globals were bad. Well, remember, global variables are bad. Global constants are very useful. So let's make a constant int and call it column size. Okay, we'll make that equal to 2. Okay, and then I'm going to make this one equal to 2 as well. And then let's go ahead and pass in some data. And let's go ahead and take a look over at the lab that we have to do today. So for today's lab, you are going to write a program that declares a 2-dimensional array where each row represents a student and each column represents a test score that they received. So just like we described a moment ago. So you're going to just manually enter this in the code. You're not going to ask the user to provide these numbers. So I want you to use, for this specific lab, I want you to use these specific values to initialize the array. All right, so I'm going to go ahead and do that. Before I do that, I'm going to go ahead and put this here in the prototype. Okay, down here as well. Okay. Yeah, see, it went way over there, so I'm gonna have to manually tab it. Okay. Oh, and that needs a comma there. Okay, so let's go ahead and minimize this so we can actually see our values as we enter them in there. So I'm just taking the numbers from here and plugging them in down here. So 78, 99, and 65, 89, and 83, and 75. Okay. So there you go. So that's we need to initialize that array with the values. Okay, and then how would we call? Again, we would have to put another set of square braces here with the column size in it. And and then in our function call, note that we don't have to do anything different. We are still just passing the name of the array to the function. All right. So let's go ahead and just go ahead and print out the first row of our array up here. So we're going to go ahead and print out num I, and then if we're doing the first row, this would be 0 for the first row, and then we're going to print out each column one at a time. Okay, so we're just printing out the value for the column for, actually, I'm sorry, we're iterating through the columns. So this is going to, confusing myself. So this is always going to be at 0. So in other words, we're going to stay inside the first row, and then it's going to increase one column at a time. So it's going to start off at 78, and then it is going to go to 99. So I'm printing out one column at a time. All right, let's go ahead and run it. And there were build errors. Because I forgot to delete this. All right, let's try that again. There's still build errors. Okay, so I'm surprised that the compiler didn't flag this, but it's missing a semicolon right there. That's why I wasn't building. Usually it would give me a red line right there, so I just wanted to make me work for that example. Okay, so there we go. All right, so printing out 78. I'll come back. Printing out 78 and then 99. So printing out the columns in that. Okay, so that's how you can pass a two-dimensional array. Now notice here that I shouldn't, because I'm printing out the columns, I shouldn't be using size here. I should be using column size here instead. All right, but let's go ahead and move on and see how we could process the elements of the array using multiple for loops. Okay, so this is just our, again, a simple example. Two different tables. There's 4 columns in each table. Initializing them, calling a show function like I just showed you. Now here's the difference. If we want to be able to print out all the different values contained within the different elements, you typically are going to do something like this. Or even to process the, the data inside the table, you're going to typically embed one for loop inside of another. Now here, in this example, notice that the outer for loop is processing the rows, and the inner for loop is processing the columns. So it's going to start off at row 0 and then loop through each column, just like in the example I showed just a moment ago, where X represents the row and Y represents the column. So in my example, I just put it 0. But in this one, because we're going to have to move through each row and each column, both of these would have to be variables. Now we've been using I for the stuff, but now we want to start to use something more descriptive like the word rows or columns. Oh, here's kind of an Yeah, this is kind of interesting here. Notice that he doesn't use a constant there. So you got a non-constant here, but you got a constant here. It's kind of funny. Anyways, okay. All right. So how would we add up? So we're going to go through 3 different examples, adding up all the different numbers in an array. So if we wanted to add up all the numbers in the array, same thing. You have a for loop with a for loop inside of it. Outer one represents rows. This one represents columns. And then we have something that we initialize to 0. And then we just add up everything for the entire array. Simple. Very, very simple. It's actually more difficult, the overhead of understanding the way that these represent either a row or a column, and passing everything and all the syntax you got to do is more tedious than the actual code itself. All right, adding up a row, and then if we want to add up the rows, instead of the entire thing, we would just do something like this, where we have this inner loop is, oh, and then now they're doing, this should sound familiar to you guys. Each row represents the test scores for one student. So just like for the lab. All right, so to get the sum of all the students' test scores, you could use a for loop that adds up each thing. So summing up the rows. Okay. And then they're going to take the average. So that's why they're summing up the row. So they're going to add up one row, and then they're going to calculate the average for that row, and then they're going to display it. Okay. So notice that each time that it runs, it's going to have to reset total to 0. Otherwise, you're adding up the entire array. Right. So you got to have it over here. You got to have it reset the total to 0. So it's the same thing for the lab. You're going to have a thing there that resets it. Okay, and then last but not least, this is, again, should sound familiar. Let's go back to the lab. So once you initialize the array, you're going to write a function called average test score, and you're going to pass it the 2-dimensional array, and it's going to calculate the average for each test. So in other words, you're going to have to add up each column and then take the average of it. So this is literally the solution to the lab. You are going to notice, and then notice how things are flipped around. Notice now the outer loop is columns and the inner loop is rows. So we're summing up the columns of a 2-dimensional array. Columns go on the outside, rows go on the inside. Versus if you're summing up the rows, it's flipped. So now rows, wait, hold on a second. Rows goes on the outside. Yeah, rows goes on the outermost for loop. Columns goes on the innermost for loop. All right, so so this is how you're going to find the average for the test. So just so you guys can see how what it's trying to calculate here, let's go ahead and do this. Okay, so you're going to add up the test and find out what we want to know what the average test score was for that particular exam. So 78 plus 65 plus 83. And to get the average, you divide by the total number of tests, which is 3, and that's where we're getting the 75.33333, 75.33333 that you see here. Okay, so use that to solve the lab. Last but not least, it mentions that you can also have 3-dimensional arrays, but we don't get into any examples of anything like that. We're not going to use 3-dimensional arrays in this class, but how do you sort of imagine that in your mind? Well, if a 2-dimensional array is like a table, like we see here, a 3-dimensional array would mean that the subscript would just represent a different table. So it's kind of like in Excel, you have different sheets, right? So you have, this is sheet 0, this is sheet 1, and this is sheet 2. Okay, and you can have as many arrays. You can have 4-dimensional. There's no limit to the number of arrays that you can have. So you can imagine if we had a 4th subscript, what would that represent? What would the 4th dimension represent? Well, it would just mean you have another set of 3 tables over here, and that would be your 4th dimension for it. Okay. All right, and that is it for today's lesson. So as usual, if you guys get stuck on anything, you need any help, don't hesitate to send me an email. in the inbox, and I will do my best to help you out. All right, good luck, everybody, and I'll talk to you again soon.